Hello, hello. My name's Evan Sinisak. I'm recording this quick demo thing for Info 6022 Physics and Simulation 2 Project 2. There wasn't really much I had to change in the main project. I kind of just copied it over. As I have in this comment at the top, usually when I do a new project that's based on an old project, I make a new project and copy all the files I need into it. But when I tried to do that for this project, it was giving me weird linker errors, even though I copied I made all the properties right. So apologies for it, the solution in this project being called Project 1. This does have everything I added for Project 2, which I really only made a couple major changes, but something that I apparently forgot to do in the first project was actually have the mesh rotate along with the particle. So now the meshes actually rotate along with the rotation of the sphere itself. So in the collision handler, well, for this project, we really only had to do add rotational force applied to the sphere when it collides with another object. So that is our planes and other spheres. I did not do any of the bonus stuff. Honestly, I was reading up on it, and it wouldn't be that difficult to implement. I'm too stressed out. I just need to be done for this weekend. So we have to add rotational force when it collides with another object, so that's the sphere and other planes, and friction, apply force at point when the sphere collides with an object or is sliding across an object. I took the friction more for just the planes. Although I guess technically the spheres could be on top of each other, so they should apply friction. I will quickly add friction to the sphere math as well after. That's gonna be annoying to implement, but I should do it. Anyways, for this, I decided to make a closest point sphere. So this just figures out when two spheres collide, this just figures out where the closest point between the two would be. That will always be their collision point. And then in our collide sphere, I kept all this stuff the same. We do our elastic momentum, and then I figure out, honestly, I don't even know if this is how you're supposed to do it. It's just how I decided to. So I get the closest point between the two spheres, figure out what the impact component between the two is using the project on, which again, not even 100% sure if I'm using the project on correctly since we used it for the plane, but it works. Kind of. Anyways, figure this stuff out. I don't even use the angular direction. So yeah, just apply the impulse at point on this on body A, apply the impulse on body B, and oh no, this is more of just a safety. This is how we handled the momentum on the linear velocity before, and then just integrate. And on the plane, again, this was stuff we just did in class. So the formula for friction on between an object and a surface is, or at least the magnitude of the friction, it is the normal force of the surface multiplied by the coefficient of friction, where the normal force of the surface is calculated by mass times gravity times cos theta, where theta is the angle that the surface is inclined at to the horizontal. And so I decided to implement the theta anyways, since some planes could be at an angle or they could be vertical, so there actually won't be any friction technically in that case. Anyways, the numerator is the absolute value of the dot product of the two planes, but since the horizontal normal will always be 0, 1, 0, we just multiply 1 by the y component of the plane. And then jeez. It is far too late for me to be thinking about math like this. Anyways, this is just the formula. I went through it. It's correct. I followed the formula as I wrote it, and it works. But basically, I figure out each component of the formula, finally multiplying by the coefficient of friction, and then friction is basically always applied in the opposite direction of the velocity. So I just get the velocity and normalize and reverse it, multiply it by the force of friction, and then apply the force at the point, and then update and call Verlet again. And then I don't remember what this is for, but it's part of the stuff that we just had. And I changed nothing in Collide, so honestly, I'm thinking about it, and I really... how would you apply friction between two spheres? Actually, that's what you would use the angular velocity for. The friction would be in the opposite direction of the angular velocity, where the force of the friction is calculated by the coefficient of friction. of each object's coefficient of friction multiplied against each other. Speaking of which, what am I using for mu? I am using mu of 0.2. The other option is to multiply the coefficient of friction on the sphere itself by the coefficient of friction of the plane, but I'm just using a static 0.2 just to show that it is working. Just trying to figure out if, okay. No, I wouldn't need these. No, because the friction... I don't know. Like I said, this has been a very stressful week. I just kind of want to be done. Honestly, I didn't even consider friction on the sphere. So if you're seeing this video and I do not resubmit it, then that means that I did not figure out how to implement friction on sphere-sphere collision. Program only runs in debug. There's still an issue with the linker for the interfaces in release that I don't know how to fix. Since this is built off of Project 1, apologies. Pressing 1, 2, 3, 4, and 5 switches between the different spheres, arrow keys, move and rotate the camera around the origin. M switches everything to wireframe, and WASD, look, now the spheres rotate. WASD move, they move very slowly now because of the friction, but sometimes I think they get stuck above the plane, so they stop. They just kind of slide instead of moving slowly. Like, I am just holding the button and it's not building up speed, but when I hit another sphere, they both kind of rotate a bit. There we go. And after I hit the little one, it reconnected the sphere to the plane. If I just kind of push the little one, you can see that the little one is spinning. So the impulse on collision is working. And they're sliding, which is good. And if I let go, then it slowly comes to a rest as friction slows it down. Watching them spin like crazy is interesting, though. Come on, big boy. Anyways, that's about all. Don't really have anything else to show. I wanted to hit the other balls with the big one, but here we go. Yeah, push him. Anyways, that's all. Thank you for your time. Have a good night. Bye.